Okay, so today we're going to go ahead and we're going to start our video that is on describing a distribution. You need to be on page 32 of your notebook. So, in your notebook, describing a distribution, you can do the entry right there. And this is going to be pages 32, 30, and it's going to go from 32, 33, 34, and to page 35. And we will talk about describing distribution. Under this is also more with describing distributions. Okay, so just remember, if you need to see something for longer, you can always pause your video. So I'm going to go ahead and go to that page in the notebook. Okay, so when you're describing a distribution, you need to remember three things. Okay? It's kind of just say they remember your socks. So we need to talk about shape, outlier, center, and spread. So for right now, we're going to skip the outliers and just go shape, center, and spread. Later on, we'll change that into the socks mnemonic. But in there today, we'll do shape, center, and spread. So, for the first thing, when we talk about shape, it's how something looked like. In Algebra 2, you may have talked about how stuff is mound-shaped or normally distributed. Okay, and also when you were younger, you also talked about modes. So sometimes they use modes to describe something. So if you have a histogram and it has one peak, that's considered to be unimodal. Like a unicycle, one wheel, one mode, one modal interval, unimodal. So thinking about that, bicycle, two wheels, so that's going to be bimodal. And then after bimodal, something just goes into multiple distributions, and that becomes multimodal. Okay, so unimodal has the one peak, bimodal has two, multimodal has more than that, so three or more. Okay, so for example here, this is an example of a bimodal histogram. Okay, you can see that they're not exactly perfectly even, but you have two peaks that stand out. Okay, and that's what makes that bimodal. Okay, so that's one way you can talk about the shape of a distribution. Okay, the next way is when we're looking at this histogram here, you can see that it goes straight across. This histogram, since it's almost straight across, is considered to be uniform. Okay, a histogram that doesn't appear to have any mode and in which all the bars are about or approximately the same height, that's considered unimodal. Okay, again, it's not perfectly straight across, but you can see it's about there. They're about the same height. Now, the next way we can talk about shape is a histogram can be symmetric. So you can see this histogram here. Okay, it's kind of got that mound shape, but not perfectly, but you could almost fold it in half. It's kind of equally distributed on both sides. Okay, that's considered symmetric. Okay, it's got that nice balance. So we have our uniform and we have our symmetric, which is another way we can talk about shape. Most of those shapes are kind of balanced that way. Now, in good pictures, these shapes are later in your notebook. So now, sometimes with histograms, you have thinner ends. Okay, the unusually thinner ends of the distribution are called the tails. So you can see, like right here, there's a tail, and right there, there's a tail. So what happens with these is if one tail stretches out farther than the others, the histogram is said to be skewed. Okay, so the skew, what you need to understand is the pull. So you can see this histogram here, how the tail is this way. Well, the tail is towards the lower values or to the left. So this can be described as skewed to the left. Or sometimes it's also called negatively skewed. Okay, I don't care which one you refer to it as, but you should know both. Now, whereas this is pulled to the right, so this is considered skewed to the right. Or positively skewed. We should probably write that in there too. So now the reason data tends to be skewed is because you have extremely high or low values. Okay, those values stick out and they skew the data. Those are considered to be outliers. Okay, you've probably heard of outliers before. So right here it says a credit card company wants to see how much customers in a particular segment of their market use credit cards. They provided you with data on the amount spent by 500 customers during a 3-month period and have asked you to summarize the expenditures. Describe the shape of the distribution. So let me put this up so you can see it. This is our distribution. Okay, so think about what that looks like for a second. So they want us to describe that. So we have different ways to describe it. So I'm going to look to see, does there appear to be a mode? How does this come? Well, I have this one peak right here. So I'm going to call this unimodal. Okay, and then I'm thinking about the shape of this. Well, it's not uniform, and it's really not symmetric. I've got these kind of values right in here. So I'm going to say this is skewed to the right, because it's kind of being pulled there. And again, if you wanted to say it was positively skewed, you could also say that. Okay. So then this just checking, don't fill anything in, but we will discuss this in class, the just checking, but you don't need to fill that in now. Okay, now we talked about shape. Now let's talk about measures of center. Measures of center, at least the first couple we're going to talk about, I'm sure will be extremely familiar. Okay, the first one we're going to talk about is the median. Now, what measures of center do is they just determine where the middle is. Okay, if you remember to find your median, you order the data from least to greatest, and there's a typo there, which is embarrassing. Least to greatest. Find the number in the middle. And then if there happen to be two numbers in the middle, you average them. So add them up and divide by 2. And you're finding the middle of the data. One thing that's important to remember about the median, and this will come up a lot, your median is resistant to outliers. Okay, so this is best to use when outliers are present. That's what resistant to outliers mean. Now on the other hand, you have your mean, which is just the average. You add them all up and divide. Okay, that's best when there are no outliers. So if there's outliers, you want to use this one. If there's mean, if there's not, then the mean. So the median when there are outliers because it's resistant, the mean when there's not outliers. So if the data is symmetric, the mean and median should be very close in value. Okay, so that's one thing you're going to notice as you're going through some of these. Now, for a recap of that, it says you want to summarize the expenditures of 500 credit card companies and have looked at a histogram. The question, you found the mean expenditure to be $478.19 and the median to be $216.28. Which is more appropriate measure of center and why? So think about that for a second. Okay, so now we need to go back to our data. If there's outliers present, it's skewed because we have a picture. Okay. If there are outliers present, so we want to use the median. If there's not, then the mean is fine. Now you see these kind of like right here. There's this value, there's this and this. This data is skewed to the right. Okay. So I'll move this up again if you didn't see that. I've got these values here. So this is being skewed to the right or skewed positively. So I'm going to say the median would be best. Okay. The data is skewed, so outliers are present. Okay. And again, I'm going to keep on recapping that. If there are outliers, you want to use your median because it's resistant. If there are not outliers, use your mean. Okay. So, some other words we need to fill in. These are just measures of spread, also known as measures of variation. And it measures pretty much how spread out the data is. That's why it's called that. Some of these are going to be very familiar. The first one is the range. Okay, you subtract the maximum value minus the minimum value. That will give you the range. Then right here, it divides into quarters, and the word is quartile, so kind of goes with the quarters. Now your lower quartile is the median of the lower half. That's the first quartile, or also known as Q1. You can call that the first quartile, but most of the time you're going to see me abbreviate that. And then Q3 is the median of the upper half. That's Q3, and that's also known as the third quartile. Okay, the interquartile range, which you can see right here, is best when outliers are present. I'm going to put IQR right here in the blank. Okay, and then over off to the side where there's a little more space, that's called the interquartile range. Okay, so I have my first quartile, my third quartile, my IQR, which is how we'll abbreviate, which stands for interquartile range, which is here. And the last thing, which you probably have talked about before, is the standard deviation. The standard deviation is pretty much the average deviation or difference from the mean. Okay, that's not resistant to outliers. So if they ask for the best measure of spread, when outliers are present, you go with the IQR. If there are no outliers, you go with standard deviation. So pretty much your median and your quartiles are buddies. Okay, you use those when outliers are present. Your median is also the second quartile, because it would be right there in the middle, divides the data in half. And then your mean and standard deviation are buddies. They are used when there are no outliers. That's when they're best. Okay? A couple more things we're going to look at. Okay, so right here, we have a 5-number summary. If they ask for a 5-number summary, you need to give me the median, the quartiles, and the minimum and the maximum. It's important that you have that memorized, what that is. Okay? That's your 5-number summary. Median, quartiles, min, max. Okay? It's also at the bottom of the one variable statistic, which I'm going to show you.